Welcome to the world of physics. Today's video is going to be about answering the two following questions. What even is physics and what has physics done for you lately? In this motivational video, I will also try to explain why, according to my opinion, some high schoolers may have the wrong vision of what physics is and how there is no proper and simple definition of physics. First, I want to start off by reading the Wikipedia definition, and then we're gonna add on to that. So physics is one of the oldest academic disciplines, and it comes from the Greek physika, which means knowledge of nature. So physics is the natural science of matter, involving the study of matter, its fundamental constituents, and its motion and behavior through space and time. Physics is one of the most fundamental scientific disciplines, with its main goal being and trying to understand how the universe behaves. But according to my opinion, physics is more than just a body of knowledge. It is also a way of thinking. And when you think about it, eventually everything comes down to physics. Chemistry is the study of atoms and matter. And atoms are the constituents of matter. So that is, matter is described by physics. Then geology is the study of rocks, earth, and astronomical objects and how they evolve through time. If we take the example from wind cells are eventually one body of airflow which exerts a force on another body of airflow, this being described by the laws of motion and force. Even technology comes down to physics because it is the way we interact with nature, which is described by physics. Thus, we can see physics as the science that underlines all the other sciences, or the study of everything. So when you ask yourself the question, what has physics done for me lately? You really need to embrace the fact that a dozen scientists have discovered everything in the history of our planet, and the other billions have just glommed onto that, or else we would be sitting in whole balls of dirt. Without those 12 scientists, neither the Industrial Revolution nor the Internet Revolution would have taken place. So when you ask the question, what has physics done for me? To Michio Kaku, here is his answer.
I'm a physicist, and some people ask me the question, what has physics done for me lately? Do I get better color television? Do I get better internet reception with physics? And the answer is yes. If you want to understand the future, you have to understand physics.
Furthermore, the main question physicists ask is how. How things interact with each other. How the galaxies are formed, and how atoms are constituted, for example. So when a physicist performs his research, his goal is either to find the definition of a measurable quantity, such as kinetic energy or the electromagnetic fields, or to find some sort of a relationship between those measurable quantities. That is, for example, the famous equation that Newton found, force equals mass time acceleration, or the famous equation by Einstein, E equals mc squared. Of course, you can describe a law using equation, but you can also set a law with graphic diagrams or some sort of model. For example, the Minkowski diagram or space-time diagram is very useful when in order to understand the special theory of relativity. I mean, you have space on one axis, time on one axis, and then you can very easily draw the motion of any body, basically. But mostly equations are used. This leads to my next point, which is about how we can see math as the toolbox of physics. So usually when I think of my math course in high school or college as a way to fill in these gigantic tools and this gigantic toolbox with all those tools that I'm going to be using in my physics course, and I'm going to be learning there how to use them properly in order to solve some concrete problems. Eventually, the end of the road, the final purpose of physics, is to find one set of fundamental group of laws to describe the way our universe behaves. Even maybe just one equation. And there I want to quote Richard Feynman, who said, hovers make gases that are very complicated, and it sort of looks like if it's all right, but I know for sure that it's not true, because the truth always turns out to be simpler than what we thought. What I find really interesting about physics is that you're able to study the infinitely big and the infinitely small as part of one subject and treat them not as opposite, but as part of the same whole, and describing them using one equation. What even is more interesting, according to my opinion, about physics is that the more discoveries that are made, the more questions you ask yourself. So, for example, when Newton found that an apple, that is a legend, but an apple was falling to the earth, he asked himself the question, why doesn't the moon fall? And that leads to amazing discoveries. Now, the question we ask ourselves is, how can we reconcile the quantum physics between relativity? And that is what allows physics to evolve these new questions and new problematics. So physics is divided into three parts: classical physics, relativity, and quantum physics, that you can very clearly see on the map right there. And for me, it's very logical to start talking about the history of physics, because in order to understand the newest problematic, you have to start back at the source of the science. So here I'm going to be talking about very quickly about the history of physics and how it can be decomposed into three parts that are ancient physics, that is medieval and Islamic physics, classical physics, and modern physics. But if you want to know more about the history of the universe, I strongly recommend the video that is going to be just below this video, called The Story of Our Universe, by also Michio Kaku. So Aristotle, which is maybe the first and main scientist during the ancient physics, based physics only on double arguments, and his principle of motion was unchanged until Newton came. Unfortunately, most of it was false, and they stated that objects won't stop until they get tired, or that the speed was proportional to the weight, or that free fall was a natural thing. He also began with his theory of 4 elements, which were the fire, the earth, the air, and the water. Although some Arabic scientists made some contributional and significant innovation in the field of optics, such as, I'm very sorry for the pronunciation, but Ibn al-Haytham, who wrote the Book of Optic, which you can see right here, influenced many scientists from the Renaissance, like Leonardo da Vinci. But the science at this point relied too much on religious beliefs, and that's the next revolution came when Galileo and Copernicus went against the thought of the church and created the heliocentrism theory, which stated that instead of the Earth, the Sun was at the center of our solar system. And then Newton makes some significant breakthrough with his three laws of motion, his contributional experience in optics, and the gravitational equation. Then there were also discoveries made in the field of thermodynamics, electricity, and electromagnetism. Even though those were not completely accurate, they made really significant progress in the right direction, and we still use them today because the calculation goes faster and they are still very accurate. Then modern physics began in the 20th century with scientists like Einstein with his general and special relativity, the Maxwell equation on electromagnetism, Planck and its length measurement system called the Planck units, Heisenberg and its principle of uncertainty, and then the Stern mode of physics, the Stern particle of physics is also common contribution that is really important and was not completed until 2012 when we discovered Higgs boson at the CERN particle accelerator. And then the discoveries of new bodies like black holes studied by Stephen Hawking or dark matter are also really important in the field of modern physics. So we are still currently in modern physics, so it is currently evolving. And the end of the road for modern physics is probably to find a unified set of laws, like string theories are trying to do, in order to reconcile quantum physics and the general and the theory of relativity by Einstein. Not only so, in order to describe our universe and solve problems, like in black holes, for example, not only at large scale, but also at smaller scales. So my last point is going to be about how we may think and students may think that physics and philosophy are completely opposite subjects, one being a very scientific subject and the other a very literary subject. But I'm going to try to deconceive that opinion and explain to you why it's not. So up until the 20th century, physics was known as a natural philosophy, and scientists studied it as part of other scientists. And until the contemporary period, physics was still strongly influenced by the church's thinking. So it was not until the 20th century that it became a distinct field, and it is still today very connected and relying on physics is still very connected and relying on philosophy. In some way, physicists have answered a lot of questions that philosophists wonder about, like the nature of time, metaphysical outlooks, for example, the multiverse and the holograms, and so, philosophy is responsible for many questions physicists ask, and physicists are trying to answer the question that philosophers wondered and wrote about. So, many scientists have written about philosophical implication of physics. So that is why, according to my opinion, students have a wrong vision of what physics is because they view it as only a scientific subject, whereas it has some literary sources. And even if we use, the physicists use a lot of the mathematic tools, it is something that is constantly evolving, and we are constantly asking ourselves in physics ethic questions and coming with new theories that are very modern and very not like the classical physics we learn in school. Then I want to finish the video by two quotes, one by Stephen Hawking and one by Richard Feynman, on advice in order to constantly be interested in science.
Here are the most important pieces of advice that I've passed on to my children. 1. Remember to look up at the stars and not down at your feet. 2. Never give up work. Work gives you meaning and purpose, and life is empty without it.
It's beautiful advice.
3. If you are lucky enough to find love, remember it is rare and don't throw it away.
You asked me if an ordinary person was studying hard would get to be able to imagine these things like I imagine. Of course, I was an ordinary person who studied hard. There's no miracle people. It just happens they got interested in this thing and they learned all this stuff. They're just people. There's no talent, a special miracle ability to understand quantum mechanics or a miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and time, then he's become a scientist.
Thank you so much for watching, and don't forget to check out my whole website and other pages and video. Bye!